Level 2 Mechanics 2018, let's do it. A water balloon launcher is made from stretchy rubber that approximates a spring, as shown in the photos below. Oliver then connected both sides of the water balloon to the launcher as shown. The launcher was held stationary with 80 newtons of pull force. The free body diagram of the launcher is shown below. Draw a closed labelled scale vector diagram on the grid below. The 80 Newton horizontal force vector has been drawn for you. Okay, so on the actual diagram, we see that there are two force vectors, F1 and F2, and what that results in is a total resultant force of 80 newtons. So basically, what we have to do is we have to draw a closed labelled vector diagram by adding these arrows head to tail. So I'm going to go ahead and do that. So let's start off with F1. F1, that's F1, and we have to label it like the question has asked us to. And then adding the tail to that head, we've got F2. Okie dokie, F2. Easy peasy. So that is worth and achieved. The next thing that we have to do now is, using the grid above or another method, calculate the magnitude of force 1. So you could count the squares, because each square is worth 10 newtons, but I want to be more specific than that. So I'm going to go ahead and do a bit of a calculation. And so to be able to work out the lengths of a triangle, we need trigonometry. And to do trigonometry, we need to have some angles. Okay, so here's what I'm going to do. I know that from the diagram, we see that we've got two angles here, 45 degrees and 45 degrees. So between our pull force, which is in this plane over here, and F1, okay, we see that that's 45 degrees. So I can add that angle to my diagram. So between our 80 Newton pull force and F1, I can see that that's 45 degrees, okay? And so this angle over here is going to be 90 degrees, okay? And we know it's 90 degrees because if we look at the actual diagram, let me get rid of all the highlighting. If we look at the actual diagram, we have got, but in between F1 and F2, this angle here. So 45 plus 45 is 90. And so between F1 and F2, we know that we've got a 90-degree angle. Okay, so now we have enough information to work out the force of F1. Before I go ahead, it is so important that when we do trigonometry, we label the sides of our triangle. So in between two angles, we've got the adjacent, which is going to be F1, and that's what we're going to work out. Then opposite the 45-degree angle, which is the angle of concern, is our opposite. And then we're left with our hypotenuse, which is our 80 Newton force. So we've been given the hypotenuse, which is 80, and we want to figure out what the F1 force is, aka the adjacent. And so with A and H as our lengths of concern, or the lengths that we're dealing with, this will tell us that we need to use our CA function, which is our cosine trig function. So let's go ahead and carry out these calculations. So cosine theta equals A over H. Substitute everything in. So we've got cosine theta, and theta, which is our angle, is 45 degrees, equals A, which is what we're trying to figure out, that's F1 essentially, over 80. To work out what A is, we need to isolate it, so I have to get rid of the 80 by timesing it by itself. Ooh, not by 10, by itself, to cancel that out. That means I have to times the other side by 80 as well. It's all symmetrical. So what we have here is A, our adjacent, equals 80 times cosine theta, which is 45. And plugging that into your calculator, what you should get is 56.757, my goodness, newtons. Don't forget your units. And yeah, that essentially is force 1. And so by working out these components, in total, we've got a merit type question.